Hi, my name is Michael Smart. I'm a Professor of Hypersonics here at the University of Queensland, and I'll be taking you through Module 6 of our Hypersonics course, where we bring all the skills that you've learnt together so that you can design a scramjet and calculate its thrust. And thrust, of course, is the name of the game when you're designing an engine of any type. But before we get into all that, let's go down into the lab and see how we test a scramjet in real life. So here at the University of Queensland, we have what we call a free piston shock tunnel. We call it T4. It's a very special type of wind tunnel that can recreate both the velocity and the conditions that you see in hypersonic flight, but only for the briefest of times. But luckily for us, that's plenty of time for us to do the tests that we need to do. Now, over the last 25 years, we've tested many types of scramjets in T4. And so we're just going to head in there now and let's see what we're testing today.
So let's just go up the tunnel and see what's going on. Okay.
So here we are at the business end of the T4 shock tunnel, and in front of us we have the open test section and our scramjet model. So above the test section we have our high frequency electronic equipment that we need to take our data in the short test time. And at the end of the facility we have our dump tank where we collect all the gases after a shot. And of course here is our hypersonic nozzle which accelerates the gases to hypersonic speed, and then they pass through the test section and our scramjet. So here we have our scramjet model mounted in the test section of our facility. The hypersonic flow passes through this, and of course we have a lot of our instrumentation and equipment connected to the model. And it really takes a lot of work to set up our model in the test section. As discussed in the previous module, it's the relative speed of the air and the vehicle that matters when you're doing a test. So in our T4 shock tunnel, our model or our scramjet is stationary, and it's the air that passes over it and through it at hypersonic speed. Now in T4 we create this airflow using shock waves, hence the name shock tunnel, and also we burst some thick steel diaphragms. So here's a typical steel diaphragm that's been burst in a shot in T4. Depending on the conditions, we can have diaphragms up to 6 millimeters thick. And obviously the higher the pressure we want to run our test, the thicker the diaphragm. As we've learned in the previous module, a scramjet's made of an inlet, a combustor, and then a nozzle. So in this particular model, we have a three-dimensional scramjet inlet to compress the air and to capture the air into the engine. After that, the air passes into the combustor where we light the fuel, inject the fuel, light the fuel, and also have the combustion occur. And in this particular scramjet, we have an elliptically shaped combustor, which we've found is an optimum shape for an efficient engine. Now, the final part of the scramjet is the nozzle. And the nozzle is where we re-expand the flow, and that's where we generate the thrust. Hey Wilson, I was just wondering if you could tell the students, what is it we go through once we have a model made? What do we go through when we when we do a test of one of our scramjets?
Okay, so what we typically do around here in T4 is that we will mount the scramjet engine into the tunnel. And then after we mount the engine in the tunnel, we then instrument the engine. And then after instrumenting the engine itself with sensors, we'll then connect all the sensors up to our data acquisition system. In addition, we also have to fit up a fuel system to the engine to supply the engine with fuel.
So Wilson, when we do a scramjet test, what sort of fuels do we use?
For the testing we do here, we typically use hydrogen and ethylene.
Yeah, oh that's great. Thanks for that, Wilson. And so what we're going to do now, we've learned about the tunnel, is we're going to go into the control room where we control the test, and we'll experience an actual shot in T4. In preparation for a shot, there's a number of tasks the experimenter must perform. The test section must first be closed and then firmly sealed with a large array of bolts. The entire test section is now moved slowly forward, smoothly connecting to the exit of the hypersonic nozzle. So with the tunnel in place, the tunnel operator and the two experimenters confer in the control room, making sure they are in agreement on the conditions required for the shot. So the tunnel operator now prepares the facility, checking gauges and that pressures are within the required ranges. The tunnel is primed and ready to go. The operator turns on the safety siren and opens the final valve. He then presses 2 buttons simultaneously to launch the piston.
Firing now.
Our shot is over in a heartbeat and the data comes up on the computer screen straight away. The experimenters can now look over the data to see if our test has been successful.